first point is that since a liquid or fluid that is moving fast reduces the static pressure, don't put things right on its path, because then you have to worry about change in the momentum of the liquid. Instead, what we will do is, suppose I connect something like this. One good way, interesting way, is to take an flowing object like that, insert a small tube. Now, if this is, let us say the water flows like that, okay, and you had some pressure there, maybe it was lower pressure, or let us say slightly lower pressure than this thing, you are going to find that it is going to go up. Why? Because that is lower, at a lower pressure, and this is at a higher pressure. Okay, so you will end up with something at that level. Let's assume it's not like a capillary tube, so there is nothing, no need to worry about surface tension, but this height difference tells us the pressure difference. Now suppose I have air blowing on top, I am reducing the pressure even more, so it will rise up even more. Right, so let's not worry about this for a minute. Instead, let us take this thing and imagine that this flowing water actually goes through a thinner tube. We are going to see very soon that the speed there will increase. Why will the speed increase? Because the area has become smaller. We will write an equation required for this, which tells us that this speed is going to be larger. So if I now connect a similar tube here, the pressure here is lower than the pressure there. Why? Because it has a higher velocity. So the pressure difference, so let us say that this pressure was P and this was P plus X. Now it will be P plus X minus something. So which means the pressure difference will be X minus Y. So it will be less than that. So if this has some height, this will actually end up with a smaller height. If I now reverse this argument, and by the way, this generally these kinds of things are used to measure the pressure of the liquid, and using the pressure of the liquid here you can actually find out the speed of the liquid. You can do both. You can use one to find the other. Now imagine that I had a glass or a beaker or something filled with some water up to this level. Okay. Now I dip a straw. If there was capillary action, you expect that this water will rise up. But if capillary action we can just ignore, let us say for now, it was a reasonably large straw, what's going to happen? Water will basically come to that level. Why? Because here you have atmospheric pressure and here you have atmospheric pressure, except for some small surface tension effect because of capillary action. It might rise up, it might not rise up, depends on the size of the tube. Let us assume it was a reasonably large straw, so we will ignore that effect. But if I now blow air, let us say I place a straw like this and I blow air this way, you know that air here is at pressure P0. So the pressure of water here is P0, because this pressure is P0, that pressure is P0. But if I blow air here, this air basically rushes out that way. You already saw that if air moves out like that, static pressure here decreases. So let us say this becomes P0 minus X. But then everywhere below it will be P0 minus X. But if this is P0 minus X and this is P0, which means this is P0, the water gets pushed up. And so this water starts to rise. You will see that the water level will be there. What if I blow faster? P0 minus 2X, this will start rising up further. And what if I make it even faster? So let us say the water should have come up all the way, but now when it comes here, it's not going to rise up like that, because it's going to actually meet dynamic pressure of air, right? Because air molecules are going to hit it this way, and so it's going to spray out like that. Okay? Will it happen? Well, it should happen. That's what Bernoulli's principle tells us. So let us try it with a simple demonstration. Okay, so let us take this. So who wants some ink on your face? Let us see. Right now what I'm going to ask you to do is just look at the level of water, okay, in the straw. Look at the level of water in the straw. Hasn't risen up much, but if it rises up, you can see. Is it rising? Okay, so I'm able to lift it up enough and make it glow. Okay, I'm not doing it for too long. I'm completely breathless now.